Hello guys, welcome once more to another video in our YouTube channel. We are going to continue solving June 2024 Pure Mathematics paper 2, and we are going to be looking at question 6. The solutions to the first 5 questions were done already, and you can check the description of this video if you're watching on YouTube to see the solutions of those questions. If you purchase the video on our website, you can just scroll up to see the other videos, and if it interests you, you can also purchase. Alright, so we go straight away to what we have for you today. Alright, so question 6 was very technical. I think this was one of the most complained questions concerning its difficulty, but I think by the end of this video you're going to see how to analyze such situations. Now this question is actually not difficult, it is just that most students are not versed with such questions, how to analyze such questions. So it becomes very complicated for them to solve this question. But anyways, after the solution you're going to realize that such problems are always very entertaining and always easy to solve. So let's go. The curve with equation y equal to 2x into 3 minus x crosses the x-axis at O and B. State the coordinate of the point B. Now, a straight line which crosses the y-axis at the point E with coordinate 0, 5 meets the curve at the point C and D as shown in the diagram. So here we have the diagram. The coordinates of the point D are K and K. B. Show that the value of K is 5 and 2. C. Find the equation of the straight line passing through D and E. D. Show that the x coordinate of the point C is 1. And finally E. Calculate the area of the region R which is bounded by the curve Y and the line DE. So the region R bounded by the curve, this curve here, and the line DE. Alright, so we are going to go straight away to solving the equations one part at a time. Okay, so guys, we are going to begin with the first part, which is saying state the coordinate of B. Now, what is the equation saying? It is saying that the curve with this equation crosses the x-axis at O and at B. Here, so we have O, which is the origin, and B is another point on the x-axis where the graph crosses the x-axis. Okay, so we need to find the coordinates of the point B. So we need the x and the y coordinate of the point B. According to the information in the equation, if you cross the x-axis, it means that your y coordinate is 0. Okay, and also if you cross the y-axis, it means that at that point your x coordinate is 0. Since the curve is crossing the x-axis at O and at B, O is just the origin, so the coordinate of the point O is 0, 0. Now we need to find the coordinates of the point B. So we use the information that at the point B, the y coordinate of the curve is equal to 0 because you are on the x-axis. So we just have to equate 2x into 3 minus x to 0. If you equate every factor to 0 and solve for x, you're going to have two values of x equal to 0 and x equal to 3. But you see that for x equal to 0, that is the coordinate, that is the x coordinate of the origin, which is the point O. Therefore, since B is away from the origin in the positive x direction, it therefore means that x equal to 3 is the x coordinate of the point B. So the point B will have x coordinate 3 and y coordinate 0. Okay, because you're on the x-axis. So we cannot take this 0 here because this 0 is already for the origin. You realize that this graph actually gets the x-axis at 2 points, at the origin and at the point B. At the origin, x is 0 and y is 0, so the coordinates of O are 0, 0. Now at the point B, x will definitely now be equal to 3 and y will still be 0 because the graph is crossing the x-axis. So we are done with finding the coordinates of the point B. Now let's go to the next part of the equation. A straight line which crosses the y-axis at the point E with coordinate 0, 5 meets the curve at 2 points, which is C and D, as shown in the figure. Now, the coordinates of the point Z are K and K. The second question says that we should show that the value of K is equal to 5 divided by 2. So we are going to analyze now the graph, okay? So according to the graph and according to the equation, we have a line which is meeting the curve at 2 points, at the point C and at the point Z. Now this line is also meeting the y-axis at the point E, and the coordinates of E are 0 and 5, which means that the x coordinate is 0 because you are on the y-axis, and the y coordinate is 5. So they have given us the coordinates of the point Z. The coordinates of the point Z are K and K, which means that the x coordinate of the point Z is K and the y coordinate of the point Z is also K. Okay, now you realize that this point Z is a point of intersection of the line and the curve. But since we don't have the equation of the line, we are just going to use the fact that the point Z lies on the curve. Okay, actually the point Z belongs to both the line and the curve. But since we don't have the equation of the line, we are just going to use the fact that the point Z belongs to the curve. Alright, if we had the equation of the line, we could simply use the fact that the point Z belongs to the line and we solve easily. But since we don't have the equation, we have to use the fact that it belongs to the curve, and we also have to solve. So either ways, we have our answer. But since we don't have the equation of the line, we are going to use the equation of the curve and find the coordinates of the point Z. Now, if the point Z belongs to the curve y equal to 2x into 3 minus x, it means that the x and the y coordinate of the point Z should satisfy the equation of this curve. Okay, if any point belong on a curve, its x and y coordinate must satisfy the equation of the curve. Remember that this curve by interpretation just means that for you to get the y coordinate of any point that belongs to the curve, you must take 2 times the x coordinate and you multiply the answer with 3 minus the x coordinate. That's the basic interpretation of this curve. So since the point Z lies on the curve, it means that the y coordinate of the point Z is equal to 2 times the x coordinate. Then you multiply by 3 minus the x coordinate. The y and x coordinate are all k. So it means that k will be equal to 2 times k into 3 minus k. Now, since k cannot be 0, because normally we don't divide both sides by k because k could be 0. But you realize that k is not at the origin, okay? K is different from 0. Look at where k is. So k is bigger than 0 and it is not equal to 0. So we can divide both sides by k. Somebody could still expand and find k, but I'm not going to expand, alright? I'm not going to expand. I'm just basically going to divide both sides by k. If I divide both sides by k, I'm going to have 1 here equal to 2 into 3 minus k, because basically the k on the left hand side cancels to the k on the right hand side. Alright, now we are going to expand. 1 will give us 6, which is 2 times 3, minus 2k, which is 2 times negative k. We subtract 6 on both sides. Negative 5 will give us negative 2k. We divide both sides by negative 2, and k gives us 5 divided by 2. So the coordinates of the point Z are x coordinate is 5 over 2 and y coordinate is also 5 divided by 2. Alright, question C. Find the equation of the straight line passing through D and E. Alright, so we need to find out the equation of this line. You realize that in the previous question we never had the equation. So if we had the equation, we could also use the equation to find the coordinates of D. But since we never had the equation, that's why we use the curve. Now, since we have the coordinates of D already, we can now get the equation. Okay, so let's start by finding the equation of the line that passes through D and E. Now, generally, the equation of a line that passes through a point with x coordinate x0 and with y coordinate y0 is just given by y minus y0 is equal to m into x minus x0. I believe you guys know this equation of the line. So all we need to find is what is y0, what is x0, and what is my gradient. So y0 is any point on the line, and y0 is the y coordinate of any point on the line, and x0 is the x coordinate of that same point on the line. Okay, so if maybe for example I choose, we have 3 points on this line. We have the point Z, okay, we have the point C, all right, and then we have the point E. So since we don't know the coordinates of the point C, but we know the coordinates of the point D and we know the coordinates of the point E, so we could use any of them. So the point E has coordinate 0, 5, okay, has coordinate 0, 5, and then the point D has coordinate KK, where our K is 5 on 2, so you are going to have 5 on 2, comma 5 on 2. All right, so your x0 and y0, you could use any of these points. So you could choose, if you want to use this point, then you have to use only the point. So x0 will be 0 and y0 will be 5. If you want to use this point, your x0 will be 5 on 2 and your y0 will be 5 on 2. But I prefer to use the first point because there is already 0 there, is going to ease the work. So using the first point, you realize that we are going to have y minus y0, which is 5, is equal to m into x minus x0. Our x0 is 0. Okay, so one thing is missing. We need to find the value of m. Now we have said that the line passes through the point D and also passes through the point E. So the gradient of the line is just change in y over change in x. Okay, so we are going to do change in y. Change in y is 5 on 2 minus 5, then divided by change in x is 5 on 2 minus 0. If you simplify everything, you're going to have -1. So the gradient of the line is equal to -1. Now we just have to replace back everything into our equation above and find the equation of the line. So replacing everything, we are going to have y minus 5 equal to m into x, and m is -1, so you just have -x. So what is y? Y is equal to -x plus 5. So that is the equation of the line passing through the points D and E. Now question D says that show that the x coordinate of the point C is equal to 1. How do I show that the x coordinate of the point C is equal to 1? Now we analyze again. The point C belongs to two people. The first person is the curve and the second person is the line. We have the equation of the curve and we have the equation of the line. So we are going to have two simultaneous equations to solve. All right, so we are going to let the coordinates of the point C to be AB. So the x coordinate is A and the y coordinate is B. Okay, small a and small b. Now the first thing is that this point C is the point of intersection of the curve and the line, so it belongs both to the curve and the line. In other words, its x and y coordinate will satisfy the equation of the line and will also satisfy the equation of the curve. So if the point C belongs to the line, it means that its y coordinate is negative its x coordinate plus 5. So that's why you see me writing b is -a plus 5, because b is a y coordinate and a is the x coordinate, and this is the equation of the line. So this is our first equation. Again, this very point C also belongs to my curve 2x into 3 minus x, which means that the y coordinate, which is b, is equal to 2 times the x coordinate multiplied by 3 minus the x coordinate. So we have these two equations and we need to solve for the x coordinate, which means that let's just try to eliminate the y coordinate, which is b. All right, so what I'll do is that I'm going to take equation 1, which has b as -a plus 5, and just replace in equation 2 in the position of b, so that everything now becomes in terms of a, and I find a. So doing that, we have, this is a b from equation 1, -a plus 5 equal to what was there in equation 2, 2a into 3 minus a. Let us expand. We have -a plus 5 equal to 6a minus 2a squared. Send everything on the right hand side to the left hand side. We have -2a squared becomes +2a squared. -a minus 6a is -7a, and 5 remains 5. So we have a quadratic 2a squared minus 7a plus 5 equal to 0. We can easily factorize into 2a minus 5 times a minus 1. And when we solve for a, you realize that if you equate 2a minus 5 to 0, a will give us 5 divided by 2. Okay, but what is 5 divided by 2? 5 divided by 2 is the x coordinate of the point D. Okay, so we cannot take 5 divided by 2, because remember that we are normally going to have two x coordinates for the point C and x coordinate for the point D. All right, because there are 2 points of intersection. but we are more focused on the x-coordinate of the point C. Since we already have the x-coordinate of the point D to be 5 on 2, we cannot take 5 on 2. So we are going to take A equal to 1 when we equate A minus 1 to be equal to 0. So with that, we have shown that the x-coordinate of the point C is actually 1. Okay, what is the area of the region R bounded by the curve and the line? So let me shade the region so that we see. So this is the region they are talking about. This coloration is not the best. Let me see if I can use so I don't know if you guys are seeing. In fact, let me just try to shade normally. So this is the region in question. So the region bounded by the curve and the line. This region that I'm shading is a region. Okay, so we need to find the area of this region. So the line is given to us. So this is a curve. The curve is this portion here, okay, from C to D, and then the line is this portion. So we need to find the area of that region. So the area under a curve is an integral. All right, so what do? We are integrating from x equal to the x-coordinate of C to x equal to the x-coordinate of D. The x-coordinate of, because we are integrating with respect to x, so we are starting from C to D. Okay, so my area is equal to the integral form. What is the x-coordinate of C? It is 1. What is the x-coordinate of D? It is 5 on 2. So I'm integrating from 1 to 5 on 2 of the curve above minus the curve below. The curve above is just the equation of my curve, and the curve below is the equation of the line. Okay, so with that, we have the area to give us the integral from 1 to 5 on 2 of what is the curve above. If you expand this, you have 6x minus 2x squared minus what is the equation of the line, negative x plus 5. Bring like terms together, we have 6x minus 2x squared, negative negative plus x, negative positive minus 5. Simplification, we have negative 2x squared plus 7x minus 5. So if you integrate minus 2x squared, you have minus 2x cubed on 3. If you integrate 7x, you have 7x squared on 2. If you integrate negative 5, you have negative 5x. It's actually from 1 to 5, not from 0. So it is supposed to be from 1 to 5. Okay, so this is supposed to be 1. So I think you have to replace the upper bound and the lower bound and subtract, and you tell me your answer in the comment section, so that I'm going to tell you if your answer is correct or your answer is not correct. Okay guys, you have come to the end of this video. Make sure you like, share, and you subscribe to the YouTube channel. Thank you for watching. See you guys in question 7. Until then, stay blessed.